Okay, so number 1 on your review says, what is the difference between an arithmetic and a geometric sequence? Well, arithmetic means that you're adding a common difference. So you might, for example, you could add 2, or maybe you could add -3, or maybe 6, or -7, but all of those are common differences. And so if it was arithmetic, and let's say the common difference, which we call D, was 3, and my first term was 1, and then my next term would be 4, and then 7, and then 10, and then 13, and so on, because I'm going to add 3 every time. Something that is geometric means you're going to multiply, which means you're going to have what we call a common ratio. So for example, I mean, you could have the same numbers. You can have 2 and -3, etc., just like we did last time, as your what we call your R value, or your common ratio. But what this means is that you multiply. So this time, if my first term was 1 and my common ratio was 3, like I used last time, so 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, and so on. So geometric, you multiply by a common ratio, and arithmetic, you add a common difference or a constant number every time, and that's how they're different. Number 2 on your review wants to know the difference between a sequence and a series. A sequence, a sequence is a list of numbers in a given order. So if you have a list of numbers, and I'll just use an example. This is what I call A1, since this is the first term, it comes first, and it can be 5. And then A2 might be 7, and then A3 might be 9, and A4 might be 11, and this can keep going forever. So again, a sequence is just a list of numbers that have some kind of order to them. However, a series is the sum, and this is the key word, sum, of all or even part of the terms in a sequence. So for example, on the last page when I made my sequence, I had it was 5, 7, 9, 11. Well, this part is the sequence. If I wanted to find the sum, and I'm going to call it a partial sum this time because I'm only going to sum the first 4 terms, that's this piece right here, then that means that I'm just going to add the first 4 numbers together. So 5 plus 7 is 12, and 9 and these two are 12, 9 and 11 are 20. If you do 12 plus 20, you're going to get 22. So the series in this case is 22. It's the sum of the first 4 terms. Number 3, 4, and 5, 6, and 7 on your review are all about arithmetic sequences and series, so that means we're going to add something. So number 1 says that I need to find the next 4 terms of an arithmetic sequence, and it gives me 11, 15, 19, and I'm looking for 1, 2, 3, 4 more terms. Well, arithmetic means you're adding something, and in this case, I'm adding 4 each time. So if I want to find the next 4 terms, I'm going to add 4 and get to 23, add 4 more and get to 27, add 4 more to get 31, and add 4 more to get 35. So those things in blue, 23, 27, 31, and 35, are my answers for question number 3. Number 4 says it wants you to find the 20th term, so what we're question marking or what we're looking for is a sub 20, the 20th term. And the problem says that I'm arithmetic, which is good. Now I know what kind of pattern I'm going to have. And that my first term, which we call a sub 1, is 3, and my common difference is 5. So, if I want to find a sub anything, a sub n, there's a formula that says you use a sub 1 plus the common difference times d minus 1. So I'm just going to plug my stuff in. I want to find a sub 20, so I'm going to plug in the first term, which was 3, plus 5 times n, which was 20 minus 1. So now you just have to plug this into your calculator. You're going to do 3 plus 5 times 20 minus 1, or 3 plus 5 times 19, and you're going to get your 20th term. So a sub 20 is going to be equal to 98. So number 5 says, describe the given sequence using complete sentences, then write the explicit rule for the nth term of the sequence. So let's do the first part. Describe the given sequence using complete sentences. Well, the sequence I'm given is -7, -2, 3, and 8. So let's write complete sentences. So let's start with the obvious. The first term of this sequence is -7. And then we can say this sequence is arithmetic. And that's because if you look at this, every time I want to go to the next term, I'm adding 5. And again, I add 5. And that is the definition of being arithmetic. You have some kind of common difference. So if I write this sequence is arithmetic, I probably should write with a common difference of 5. And now you've described the sequence using complete sentences. When I add another page, I'm going to now do the second part that says write the explicit rule for the nth term of the sequence. Well, you know this is arithmetic, and so you have a formula. To find the nth term of any arithmetic sequence, you have a sub n equals a sub 1 plus d times n minus 1. So all we need to do is plug in. So we're going to write a formula for the nth term, so I'm going to keep my a sub n equals my first term in this case is -7 plus my common difference is 5 and then n minus 1. And this is explicit because if I want to find, let's say for example the 6th term, that means I explicitly just have to plug 6 in and I will find my answer without having to do too much work at all. Number 6 wants you to find the sum of the arithmetic sequence that is 2 plus 9 plus 16 plus ... 58. So this is a little bit of a tricky problem. Well, there is a formula, so to find the sum of an arithmetic sequence for the first n terms, it's s sub n equals n over 2 a1 plus an. So this is tricky because I know the first term and I know the last term. This 2 is my a sub 1, and the last term, this 58, is my a sub n. But what I don't know is the n, or what term the 58 is. I don't know if it's the 5th, 6th, 7th, 8th, 9th. I don't know what term number it is. So first things first, we have to find that out. So I'm going to use the explicit formula for an arithmetic sequence. So I'm going to use a sub n equals a sub 1 plus my common difference times n minus 1. This nth term that I'm trying to find, I know that it's 58. I know my first term is 2. I can look at the sequence and say that my common difference is 7, because to get from 2 to 9, I have to add 7, and to get from 9 to 16, you have to add 7, so my common difference is 7, and this n is actually what I'm going to solve for. So I'm going to subtract 2 and subtract 2, and I'm going to get 56. Now I have 56 equals 7 times n minus 1. I'm going to divide both sides by 7, and then 56 divided by 7 is 8. And so I have 8 equals n minus 1, and so now I'm going to add 1 and add 1. So now I know that n equals 9. So this 58 right here is the a sub 9th term, which now tells me I'm trying to sum the first 9 terms. So my formula again was s sub n equals n over 2, a sub 1 plus a sub n. Well, I know again that I'm trying to sum the first 9 terms, because we just figured out that that 58 is my 9th term. And so I'm going to put 9 over 2, and then I'm going to do the first term, which is 2, plus my last term, which was 58, and I'm going to solve it. So s sub n, or s sub 9 in our case, oops, this right here should have been a 2, sorry. S sub n, or the sum of the first 9 terms, 9 divided by 2 is 4.5. And then 2 plus 58 is 60. So if you type 4.5 times 60 in your calculator, you're going to get s sub 9 equals 270, which means when I sum up or add up the first 9 terms, they total or add up to 270. Okay, so number 7 says that a farmer bales a field of hay each trip around the field, and then each trip around the field gets shorter. On the first trip around the field, there were 267 bales of hay. So 267 is my A1. On the second trip around the field, 253, so my A2. On the next trip around the field, there were 239, which is my third term. How many bales of hay will there be on the 7th term? So clot, clot, clot. I want to find a sub 7. Okay, so I know that my first term is 267, and my second term is 253, and my third term is 239, so I need to figure out how I'm going from term to term. And so if you subtract, if you do 253 minus 267 in a calculator, you're going to get negative 14. And then I need to do the next two also. 239 minus 253 in a calculator also gets you negative 14. And so since the common difference between each term is the same, I'm going to subtract 14, I'm going to subtract 14, that means that this is arithmetic. So if I want to find the 7th term, again, I'm going to use that formula that says a sub n, my nth term, equals my first term plus my common difference times the number of terms minus 1. So I want to find the a sub 7th term. My first term was 267. My common difference is negative 14. And then I'm going to plug in a 7 minus 1. And you can actually just type this whole thing in your calculator. And you should get that on the 7th trip around the field, the farmer is only going to be able to make 183 bundles of hay. And we're going to label it because word and story problems have story answers, not just 183, but 183 bundles of hay. Okay, so now we're going to move on to 8, 9, 10, 11, and 12, which are geometric. And so number 8 says, find the next two terms of the geometric sequence. So I have 567, 189, 63, and then I need to find the next two terms. So what you're going to do is you're going to take 189 and divide by 167. And then you're also going to check 63 divided by 189. Both times when you do this, you should get 1/3. So that means instead of adding or subtracting 1/3, we're actually going to multiply my number by 1/3. So to find my next term, the one that goes right here, I'm going to take 63 and multiply by 1/3. 63 times 1/3 is 21, and then you're going to take 21 to find this next term and multiply by 1/3, and you're going to get 7. So my next two terms were 21 and 7. So number 9 says the fifth term, I would need to find the fifth term of a geometric sequence where a sub 3, the third term, is 20, and the common ratio is 2. So the best way I can help you understand this problem is I'm going to draw it out. So this is my first term, or my a sub 1. This is my a sub 2. This is my a sub 3. This is my a sub 4. And this is my a sub 5. So I know a sub 3, or my third term, is 20. And I know that to go from term to term, I have to multiply by r, or 2. So if I want to go from the third term to the fourth term, I have to multiply by r, which is 2. And if I want to go from the fourth term to the fifth term, I have to multiply by r again. So there's a formula that says to find the nth term of a geometric sequence, you take the first term and then you multiply by r to the n minus 1 power. And we're kind of going to use that formula, but we're going to derive it a little bit. So just bear with me for a second. I want to find the fifth term. I want to find this fifth term right here, a sub 5. Well, I don't know the first term. Right here in the formula it asks me for the first term. I don't know it. And you could go back and find it, but let's use what we know. I know the third term. So my third term is 20. And we've already talked about how if I'm at 20 right here, my 20, that I have to multiply by r 2 times to get to my a sub 5, or my fifth term. So let's do that. Let's multiply by r 2 times r, which is known as r squared, and in our case, we don't have r. Our r is 2. So it's going to be 2 squared. So down here I'm going to put 2 squared. And so if you do 2 squared, you get 4, and 4 times 20 is going to get me an answer of 80. So my fifth term is 80. But I just want to make you realize something. Watch. A sub 5, to find my fifth term, I plugged in my third term and raised it to the power of r squared. Now watch. I used my third term and raised r to the second power. 2 and 3 together added up always must equal the 5 or whatever number you had over there. Okay, so number 10 says write an equation for the nth term of a geometric sequence, and it tells you the first term is negative 10.5 and the next term is negative 5/2. Well, first things first, we definitely should either write this as fractions or as decimals so we can figure out what's going on. So let's redo this. I'm going to do negative 10.5, comma, and if you don't know, you can type 5/2 in your calculator, and it will give you the decimal approximation, or the decimal equivalent, which is negative 2.5. And then this is going to keep going. So we need to figure out how we got from negative 10.5 to negative 2.5, and we know that it's geometric, so to do that, we're going to divide. So negative 2.5 divided by negative 10.5, and we should definitely get a positive answer, because a negative divided by a negative is a positive. So if you do 2.5 divided by 10.5, you should get 5/21. So that means I'm going to multiply everything, or each term, by 5/21 to get to my next term. So now the question was to write an equation. So to write an equation for a geometric nth term, it's going to be a sub n equals my first term times my common ratio to the n minus 1 power. So now that we know all of this, we can do that. To find my nth term, a sub n, it's my first term, which is negative 10.5. And I'm going to multiply by my 5/21 raised to the n minus 1 power. And that's my formula. Okay, so problem number 11 says 486 and then has 1, 2, 3, 4 blanks and then goes to 2. And I want you to fill in the blanks. So what we have to know is that we multiplied by something 1, 2, 3, 4, 5 times, and that's something we call r. So if I wanted to write an equation, I started with 486 and I multiplied by r, 1, 2, 3, 4, 5 times. And when I did that, I got to 2. So all we're going to do is just a little bit of math. So I'm going to first need to get r by itself. So to do that, I need to divide by 486 on both sides. So if you type in the calculator, 2 divided by 486, it should reduce the fraction for you down to 1 over 243. So you have r to the 5th power equals 1 over 243. Now, to get the r by itself, and I just want to use a different color for a second and have a little thought over here. If you had x squared equals 36, you would take the square root of both sides. Well, we don't have that. We have r to the 5th, so you're going to do the 5th root of both sides. And when you type that in your calculator, it's going to tell you that r equals 0.3 repeating, or 1/3. So now you know what r is, but that's not your answer. That tells you how to get from term to term. So to find my next missing term up here, you should take 243 and multiply by the 1/3. So when you take that 486 and divide by 1/3 in the calculator, you're going to get 1. Oops, I did not mean to do that. Let's try that again. You're going to get 162. And then you're going to take your 162 in the calculator and you're going to multiply by 1/3 again, and you're going to get 54. And then if you take 54 and multiply by 1/3 again, you're going to get 18. And if you take 18 and you multiply by 1/3, you're going to get 6. And then if you take 6 and multiply by 1/3, you should get your 2. So there, now you've filled in the answers, or the missing terms: 162, 54, 18, and 6. Number 12 says that you complain that the hot tub at your hotel suite is not hot enough. The hotel tells you that they will increase the temperature by 12% each hour if the current temperature of the hot tub is about 75 degrees. What is the temperature of the hot tub after 3 hours to the nearest tenth of a degree? So right now, we want to find the nth term. This is geometric because we're going to multiply by something. And there's a formula to find a term. It's the first term times r to the n minus 1 power. Well, to find out how hot the hot tub's going to be in 3 hours, you're going to take your first term, which is 75 degrees, and this is the tricky part right here. You want to multiply by 1.12, not 0.12, but 1.12, and then you're going to plug in your 3, and then minus 1. And I just want to talk about this for a second. The temperature is increasing by 12%, so you're keeping 100% of your original temperature plus 12% additional temperature. So this is really 112%, and 112% as a decimal is 1.12. And so now all you have to do is type this thing that I'm boxing in blue in your calculator. So you took that box thing and you typed it in the calculator, and the calculator is going to tell you that a sub 3 equals 94.08 degrees. But make sure you read the problem and answer what it said. It says, what will the temperature be in the hot tub after 3 hours? And then it says round to the nearest tenth of a degree. So to get the problem right, a sub 3 is going to be 94.1 degrees. And there is our answer.